Okay, let me move on. My kind of last example. I have the integral of 1 over x cubed from negative 1 to 2. So once again, at first glance, this seems like a pretty a safe function to integrate. If it's not going all the way to infinity, so what's wrong with this thing? So once again, if you notice, you will see that 1 over third root of x, it doesn't exist at x equals to 0. If you look at the graph for this guy, it actually looks something like this. It looks like something like this. So the function doesn't actually even exist when x equals to 0, and yet I have to find the integral, which is kind of like this area here. So this is kind of a pretty weird region to look at. So to actually deal with this, I'm gonna have to break this guy into two pieces. So to find this integral, instead of integrate from negative 1 to 2, a safe way to deal with this is to break it into two pieces and integrate first from negative 1 to 0 of the function plus the integral from 0 to 2 of the same function. So that means I'm going to have to break this guy into two pieces and use the improper integral twice. Okay, it doesn't look too bad, so let's do it. This one, that's going to be the limit when n goes to 0 of the integral from negative 1 to n, and it's going to be 1 over third root of x dx. And that's going to equal to when limit when n go to 0. The integral of 1 over third root of x, I'm just going to write it on the side here. 1 over third root of x is the same as x to the negative 1 half. If you integrate x to the negative 1 half, you're going to get x to the 1 half plus 1, which is 2 half. 1 third plus 1, which is going to be 2 thirds, divided by 2 over 3, which is the same as multiplied by 3 over 2. And this makes sense because if you take the derivative of this guy, 2 thirds come down and cancel out with 3 half. If I reduce 2 thirds by 1, I get negative 1 third, so this makes sense. And this goes from negative 1 to n. Okay. Oh, it should be 4 thirds. Wait a minute. Wait, you add 1 or you subtract 1? I forget. When you integrate, you add 1 to the power, right? So you add 1 to negative 2 thirds, so you get 2 thirds, right? We good? Okay. Wait a minute. Right? Okay, I think so. Negative 1 third, 2 thirds. You add 1. Yes. Okay, good. So that's a good point. Anyway, on your exam, when you try to do the integral, make sure you don't find the derivative. So some people get confused between integral and derivative. So this is going to be n go to infinity. N go to 0 of let me see 3 half n to the 2 thirds minus 3 half negative 1 to the 2 thirds. Okay. So What is the limit of n to the 2/3 when n go to 0? When n to the 2/3 is like the third root of n squared. So the third root of 0 squared is the third root of 0. So that's going to be 0. And then what is negative 1 to the 2/3? Negative 1 to the 2/3 is going to be 1. So that's going to be negative 3/2. So this thing is going to be just negative 3/2. Okay. So that's kind of mean this integral here. It represents this area, and that's going to be negative 3/2. Okay, that's not too bad. Let me now try the second half. Again, this is, I'm going to rewrite the 0 by n, so it's going to be limit n go to 0 of integral from n to 2 of 1 over the root of x dx. And I already did this integration, so it's going to be 3/2 times x to the 2/3, and it goes from n to 2, and that's going to be the limit when n goes to infinity of 3/2 times 2 to the 2/3 minus 3/2 times n to the 2/3. So lucky for us, I have already did something in the first half. So for the second half, it's just the same function, but the limit goes differently. Now then, what is this chunk? Let me see, 3/2 times 2 to the 2/3. It's going to be just 3/2 times third root of 2 squared, which is 4. And then this guy is going to be 0, so let me just leave that up. So that's going to be my second piece. So this is 3/2 times third root of 4. So that means this entire integral is just going to equal to the sum of the two, and that's going to be just negative 3/2 plus 3/2 the third root of 4, and that's it. So integration by parts is used when you have integrals that involve infinity. But there are also a case when you have an innocent looking function and the integral doesn't go all the way to infinity. However, that innocent looking function is actually undefined at some value on the graph. By undefined, I mean the value, when you take the limit, it goes to infinity or negative infinity, or it can actually go to two different places in one case in this example. So to deal with that, you have to use the sneaky integration by, integration, what is this called again? Improper integral. So I'm just gonna write the integrate, instead of integrate from negative 1 to 0, I just replace that number, that 0 by big N, and take limit as n equal to 0. So that's the safe way of doing it. The last one, I like to find the area between the graph of 1 over the root of x and the x-axis on the interval negative 1 and 2. So this is almost like the previous problem, except that the problem is asking for area. So when I have to find area, I just have to treat the piece that lies below the x-axis as having positive area. So the area here is going to be just 3/2 plus 3/2 times the root of 4. So the answer here is different, by the way, because of that word area. So whenever I need to find area, once again, I need to just convert everything into the positive realm.